All right, the final two examples. So number 11, if you take a look, our exponent has the variable. And you would think, well, there's something I might need to do there. Let's go ahead and plug in our approaching C value into that. I'm just going to write the little negative, even though it's 0. If you recall, this is 1. Anything to the 0 is 1. So this is what we have, and we get 5, which is all you needed to do for this one. So, number 12. All right, let's go ahead and plug in our approaching value of a 4. So we get 4 plus 12 minus 4 over 4 minus 4. And if you notice, that gives us the 0 over 0. So what is that telling us to do? More. And if we have that radical, then we are doing the conjugate. All right, so that conjugate, remember, is the opposite sign. So first we have what we are starting with. And then we are multiplying it by the conjugate. And so since that was a minus 4, this is a plus 4. Keep that radical over everything. So now we are going to do FOIL in the numerator, those two, and in the denominator, I'd like us to keep it as separate factors. So when we do FOIL in the numerator, we end up getting, let's write this out, as it's heading to 4, we end up having the x plus 12 minus 16 over the x minus 4 square root of x plus 12 plus 4. So if you notice, we simplify this. We get x minus 4 over the x minus 4. And if you can see, that is going to end up reducing to 1. So we have those going to 1. And we get, continuing on with our simplifying, we have 1 over x plus 12 plus 4. Now we can plug in our C value of 4. And if you notice, we should end up with 1 over 4 plus 4. So we end up with 1 over 8. So those are the solutions for the limits for 11 and 12. Let's just look at a few of these rules that might apply at various times when we are calculating limits. So initially, we're just going to say we have a function that is approaching a, so our output we're just going to say is a capital A. We have the function as it is approaching a, and we're going to just say that's a capital B. So for the very first one, it talks about if we have a constant. So if you take a look, we're given this constant C, and let's say we want to have the constant times the function. Our limit is actually going to be that constant K times the limit of the function. Number 2, if we have two functions we're adding together, the limit are the output of those limits. So in other words, it's kind of like that sum and difference terminology. So then the next one is saying if they are being multiplied, then the actual output limits are multiplied. So this is the limit of the product, is the product of the limits. Number 4, if two functions are being divided, then the limits are divided. So this is the limit of a quotient, is the quotient of the limits. The next thing, if we have a polynomial like we've been working with, we can plug in that limit, the c value, and we get the limit at that value, which is the output. And then the next one, if we have an exponent as a constant, it ends up being the limit to that exponent. So then, for number 7, if we have two functions that are equal, their limits would be equal. And that's only if they are given they are equal. The next two, we do not have to worry about. All right, you guys, that's the end of the examples. See you next time.